Welcome to all in the fifth day of Introduction to Machine Learning course. So today we will discuss mathematical understanding, which was discussed earlier, and we will continue with types of machine learning. So in mathematical understanding, we discussed that a data set T is comprises of two types of features: a set of features X, which may contain multiple features from x1 to xn, so n number of features are there, and a target feature Y, which is a function of x. The task of learner is to estimate the function fx. So here we represent that estimated function as y cap or f cap fx, and from the data set D using the machine learning algorithm, where the estimated function y cap is equals to actual function fx plus some error. So the task of learner is to estimate the function fx such that this error epsilon reduces or minimized. And the task of reasoner is to compute the estimated or the predicted value of fx for a new value of x. So here, continuing in the same way, the types of features, that is the value of x and y, can be categorized into four categories. As you can see that both the features, whether this x or y, they can be categorized into four categories. Number one is the categorical feature. Categorical in the sense those features which has the category as their values, like blood group. So blood group do not have any integers or real values. They have a category like A positive. So this is one category of the blood, right? So therefore this kind of feature is categorical feature. One more example of the categorical feature would be the rank that you have obtained, the CPI that you have obtained, like you obtained A plus grade, the grades you obtained in the scores, that is the category that represents a particular range of values. So if your values lies within a range, that is represented by a symbol, that is category, right? Then if the categorical values, they have some order associated with them. For example, the height of a person. So if the height of a person lies in a range, then we call him as large, either medium or small height. However, in this large, medium, and small, they are categorical. They are representing some range of values, but they have one order associated with them. That order is that the large representing the highest height and the small representing the smallest height, right? Similarly, medium is in between them. So when a categorical variable got some order associated with them, then it becomes ordinal variable, right? Similarly, the third category is integer valued features. So the features whose values is can be represented in the form of integers. So the values which can be represented using frequency. So like number of students in a class, so that could be represented by an integer. Therefore, that is the integer value feature, right? Similarly, there is a real valued feature. So real valued features such as height of a person and the weight of a person. These are the values which contains fractional values. So they are real numbers represented by real numbers. So the both variables, whether it is x or whether it is y, that is the feature and the target feature, they both can be of these four types. Further, the category of this x and y, broadly they are categorized into two types. Either they could be discrete or they could be continuous. Discrete in the sense that they can be represented by digits, complete digits like integer values numbers. They are the discrete numbers. And continuous in the sense that they have continuous interval. They have their range in a continuous interval, that is the real valued numbers, right? For example, here we have a data set. This data set comprises of, see this table. In this data set we have four features: height represented by x1, age represented by x2, complexion represented by x3, and weight represented by x4. Here you can see that height is a real valued feature since the values are represented by real numbers, while age and weight are the integer valued features. But here you can see they are integer values, they are represented by integer valued, but really they are integers. This is a question to be asked. So usually weight is a fractional number represented by real number. So usually it will be a real valued feature. Similarly, the complexion. Can you tell me which category the complexion belongs? Whether it is categorical or ordinal. So if you closely observe it, you will find that it has two values, fair and dark. So is there any order associated with them? If fair is more good, is there any order? So since there is no ordering over it, right? Therefore, it is a categorical feature, right? So then we continue with this way. Based on that, we classify the machine learning techniques into three categories. The very first category is called as supervised machine learning. So what is supervised machine learning? The supervised machine learning is where we have both the variables associated with the algorithm. That is, we have the feature X as well as its associated feature, that is the target feature Y. Then the machine learning algorithm is called as supervised machine learning algorithm. Then this supervised machine learning algorithm could be of two types, either classification or regression, right? So in classification, if the Y, that is the target variable, is discrete, then the machine learning algorithm, the supervised machine learning algorithm becomes classification. However, if Y is continuous, a real valued feature, then the same problem becomes regression. For example, here you can see we have the same data set which we seen in earlier slide. We took height, age, and complexion from that slide, from that data set, and we represented height by x1, age by x2, and we make y as a complexion as a y feature, that is the target feature. Now here you see that target feature is a discrete value. It is a category representing a category, and category, that means, is a discrete value. So therefore, this problem, designing a model from this data set which can tell us the category of the complexion, will be a classification problem. So for example, if we want to predict the value of complexion for height is equal to 2.5 and age is equal to 5, that means we are interested to know the category of complexion. Therefore, this problem becomes classification. Now consider another problem, the same data set with height, age, but however now as y we have weight. So since this weight is a continuous variable, right? It do not have any category. Weight could be a real number also. Therefore, here if we want to predict the value of weight uh, based on the value of height and age, then this problem becomes a regression problem, right? So this is all about today. The rest will be discussed in coming lectures. Thank you.